Now that we've learned how to solve equations, we're going to do them while using algebraic properties. And be sure that you print off these notes, this table here, which is from the Virginia Department of Education. It does a really good job of spelling everything out and making sure it's presented in a nice table format that you can look at later. Okay? So this is in the table, the assignment table on the website, so you can find it there. So we're going to be using the associative, commutative, identity, inverse, and distributive properties, and also the multiplicative property of zero, zero product, reflexive, symmetric, transitive, addition, subtraction, multiplication, division, and substitution. We're going to be using all of these properties when solving equations. And just to make it easier, I've decided to redo the same equations that we've already done in previous videos. So I'll just go through and work some of these. The trick here is when you're using algebraic properties, you have to write down which property you're using for every step that you do. So let's consider the equation 3 plus x equals 8. So 3 plus x equals 8. Okay? If that's our equation, then we know that we need to subtract 3 and subtract 3. So the property that we're using there is the property of subtraction. That's the property we're using. And so then we get our answer, which is x equals 5. Okay? Easy, right? Okay. Another example. Let's look at 5 equals a over 4 plus 2. Okay, so what's happening to a? It's being divided by 4 and then added by 2. So if we're doing inverse operations, the first thing we're going to do here is subtract 2, which again is going to be the subtraction property. Okay, and so then we balance, and we get 3 equals a over 4. And now we need to multiply by 4 on both sides. So this is the multiplication property. Okay, and so we balance again and we get a equals 12. Okay. What about so what about something like this? Okay, let's go crazy with this one. Let's do 5n plus 34 equals negative 2 times quantity 1 minus 7n. Okay? So we just do this exactly the same as we would before. So looking at the 2 here, we could divide both sides by negative 2, but over here we're not going to really get much. This will give us a 17 if we divided that by 2. But the 5 is not going to divide into 2 very well, so I'm going to suggest that we distribute first. Okay, we distribute right there and right there. So when we balance, okay, we get 5n plus 34, because we haven't done anything to that side. And here we're going to get a minus 2 and a plus 14n. Okay? And this was because of the distributive property. Okay. And so now we're looking at combining like terms. If I move the ends all over to the right-hand side, I can keep them positive, which is really no mathematical benefit. It's just what I normally do. So let's subtract 5n and subtract 5n. Okay. And there's a couple of ways that I want to talk about this, and really I should have mentioned this up here also. We can subtract 5n from both sides, and this is technically the subtraction property, just like we've used here and here. But the subtraction property is also the same as the additive inverse, right? Which, if we're looking at right here, the additive inverse is saying that a plus a negative a equals 0. But that's really kind of the same thing as the subtraction property. So these are actually kind of the same things as that, and the division would be the inverse of multiplication over here. So really they are the same things. Okay? So when you say subtraction property, you could also really say the additive inverse property, and I'll just show you what I mean by that. Let's say that we are adding a negative 5 here, and adding a negative 5. Then I would call that the additive inverse property. Okay? And so then a 5 plus a negative 5 is, of course, the additive inverse property, so we're getting 0 out of that. Here we'll have 34. Here we'll have a negative 2. And here we'll have 14 plus a negative 5. This is the same as saying 9 in n. And now we need to add add 2 and add 2. Of course, this is the addition property. Okay, the addition property. And so then we're getting 34 plus 2 is 36, and negative 2 plus 2 is 0, and we have a 9n. Now we're dividing by 9 and dividing by 9, and of course this is the division property. Okay, and so then those cancel right there, and we're left with 4 equals n. Whoops, 4 equals n. Okay. Now, I want to do one more like this just so you can see these really at work. So, we are going to do one more. One more example. And that example is going to be another great big fancy one. Negative 3 times 4x plus 3 plus 4 times quantity 6x plus 1 equals 43. Okay. So, looking at what we need to divide by, 3 and 4, if we divided everything by 3, we're going to get a fraction here. If we divided everything by 4, we're going to get a fraction here. So what I'm going to recommend doing is distributing and then seeing what happens. So this is obviously the distribution property. The distributive property there. And so negative 3 times 4x is negative 12x, and negative 3 times 3 is minus 9. And 4 times 6x is 24x, and 4 times 1 is 4. And all of that equals 43. So now we can just combine terms. Negative 12 plus 24 is going to give me a positive 12x, and negative 9 plus 4 is going to give me a minus 5 equals 43. And you don't really need to cite a property here. This is really just combining like terms, which I usually abbreviate as CLT. So we don't even really need to cite that, because it's not an algebraic property that we're using. Okay, however, now we're going to add 5 to get this 12 by itself, because again, you ask yourself, what's happening to x? It's being multiplied by 12 and then subtracted by 5. So we're going to add 5 using the addition property. Okay, and so then we're going to have 12x, and that equals 48. Now, of course, we're going to divide by 12 and divide by 12, and we're using the division property. Okay, and so then we're going to have x equals 4. And to finish up the video, I just want to make one clarification about the relationship between subtraction and division and the inverse property. Okay, so because multiplication and division are inverses of each other, and addition and subtraction are inverses of each other, these are related by an inverse relationship. Okay, that is why they are the same kind of property. So in a scenario like this, where I said divide by 12 using the division property, I also could have said, let's just revisit this. Let me just take this whole step here, and this would be an alternative. An alternative method right here. Okay, let's just say that I had wanted to do this a different way. Okay, the same step, just taking the same step right there. 12x equals 48. And instead of dividing by 12, I could also have multiplied by 1/12. It's the same thing. Multiplied by 1/12 because I wanted to multiply by the multiplicative inverse of that 12 right there to make it go away. And so this would be the multiplicative inverse. Okay? And so then if I multiply 1/12 by 12x, then I'm going to get 12x over 12, and I'm going to get over here 48 times 1/12 is 48 twelfths. And then I can just divide this out. 12 divided by 12 is the same. 48 divided by 12 is the 4, and we would be right back up there.